Lesson 4-1, which is entitled Coordinates and Distance. Hopefully by the end of this you can say, I know the Pythagorean distance formula and how to use it. Just take special note on this one because this will be one of our proficiencies, and so taking good notes now will then allow us that next class period to hopefully pass that proficiency right away. So again, as you probably realize, that the Pythagorean is it's going to be something about the Pythagorean theorem, but then we're going to kind of add an extra step to it, or not necessarily an extra step, but we're going to manipulate it a little bit. In order to do that, we need to kind of review a little bit about coordinate planes and graphs. And so I know that this was something that you dealt with a whole lot of last year. But a coordinate plane is formed by the intersection of two perpendicular number lines called axes. So again, we have our, as you remember, the x-axis goes left and right, and the y-axis goes up and down to create the space made up, which is called the coordinate plane. Now realize that our quadrants here, so it, again, draw it if you need to, but know that our quadrants start off, and there's 4 of them. Starting off with our top right one, we have quadrant 1, quadrant 2, quadrant 3, and quadrant 4, then going counterclockwise around. And know that whenever we say a quadrant, we always use a Roman numeral number, so that's why it looks like I and II and 3 I's and then IV here. The point of intersection of the axes is what we call the origin, as you know, which is 0, 0, which if we are going to actually plot points, we would start at the origin and then go left or right first and then up or down based on whatever our coordinate point is. So our coordinate points are described by using what's called ordered pairs. An ordered pair consists of an x-coordinate and a y-coordinate and is written x comma y. So please remember again that the x-coordinate tells you how many units you move to the left or right, and the y-coordinate would tell you how much you actually move up or down. If you could take a moment right now, I would like you to basically just think about the ordered pairs A, B, and C, and I would like you to kind of guess. Just tell me right now, what is the coordinate of point A? What's the coordinate of point B? What's the coordinate of point C? And so again, you have your x's and you have your y's. So take a moment right now. Tell me what A is, tell me what B is, tell me what C is. If you need to pause the video, please do so. And so hopefully you have the 3 written down, because then it's just going to help you visualize as we go through and we start to develop the formula. But A, you should have gotten that it is 110, because I went to the right one and then went up 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. B is at 1, 1, and C is at 8, 1, counting across to get those points there. Now, what I'd like you to think about a little bit is, what's the distance between A and B? What's the distance between A and B? So if I was going to figure out the length of AB, hopefully you said to yourself that it's 9. Now again, if I asked why you got this or how you got this, you would probably say that you counted the squares. And if you counted them, they would be 9 across. But I want you to take a look at the coordinate points. What about A and B tell us that it would be 9? Think about that, because we're going to talk about that in class. Think about what part of A and B could also, instead of actually counting it, would you be able to tell me is that the distance between A and B going up and down, thinking about what axis actually goes up and down, would get 9. Same thing with B to C. If you told me, okay, so if I asked from B to C what's the length, hopefully you'd be able to say that it's 7. Could you look at the coordinate points here and be able to tell me, knowing that I'm going from the left to the right, thinking about the axes that goes left to right, how would I get 7 possibly from these ones here? Now the next question is how then would I get AC? How could I get the length from A to C? And this is going to go back to basically, again, thinking about Pythagorean theorem, where if I count the number of squares up and I count the number of squares right from my point B here, I get a triangle. if I connected all those points there, thinking about that AC is the hypotenuse. So hopefully you'd be able to take this time and sit there and say, well, remember a squared plus b squared is equal to c squared. So 9 squared plus 7 squared. You would then do all your math, and you should end up with 11.4. Now again, if you forget how to use the actual Pythagorean theorem, we will go through it again, and I'll have a detailed kind of explanation of it. But remember back to how you would actually figure this out. You do 9 squared, 7 plus 7 squared, so 81 plus 49. Add those two together, and then take the square root of those two to get 11.4. Now, in certain situations, I'm going to ask you to plot the points -2, 5, and 4, -3. Again, this is just the first lesson, so it's kind of some part of a review, some part a more explanation of it. But if I have -2, 5, I'd plot the point, I'd go left 2, and then I would go up 5, just because that -2 there. Now, 4, 3, I would go to the right 4, and down 3. And if I was going to ask you to basically, what's the distance in between these 2 points here? The easiest way to figure out those distances is exactly what we did just to find AC, is we need to figure out what's the length going down from one point and what's the length going over. So if you count the number of squares up, so we'd have how many? 1, 2, 3, 4, 5, 6, 7, 8. 8 squares down. How many squares over? You should count it, and it should be 6. Now, if I was going to ask you basically what's the distance in between these 2 points here, again, using the Pythagorean theorem, so if I slide those two things over, I'd start with a squared plus b squared is equal to c squared, and I'd plug in my legs, so I'd have 6 squared plus 8 squared. A and b doesn't matter, I could have 8 squared and 6 squared switched around, that's fine. But 36 plus 64 is equal to c squared. And then I get 100 is equal to c squared, and then finally taking the square root of both sides, because again, c is the length, not c squared. If I take this, how do I get rid of a square? I take the square root, which is 10. Now, this is based off of what we did last year. This year is going to basically, instead of having to graph it and then be able to figure out the distance in between them, we're going to take the 2 coordinate points here, and we're going to use a formula called the distance formula to figure it out. Now again, the distance formula is going to be our proficiency. I know this looks really, really complicated, but if you just write it down, and I will explain through it. So pause right now, and I want you to write down, all right, all this information for your notes. It's going to become really important that you see this and you practice this. The distance formula is basically meaning the distance between the points, the first point, which has the first x coordinate, the first y coordinate, and the second point, which is the second x coordinate and the second y coordinate. We would say that distance, so the length, is equal to the square root of the x coordinates squared, plus the y coordinates subtracted, and then squaring that. Now, if I go back for a second and actually look at the previous slide, just for a quick second, and I look at the Pythagorean theorem, so I have a squared, which is the length of going from left to right, and b, which is the length going up or down, squared, is equal to the hypotenuse squared. And I take back a look at the distance formula that I have. I have the x coordinates, which moves left to right, so the distance in between the second and the first. I take that squared, so that would be kind of a length of our bottom triangle, our one of our legs squared, or a, plus the length of our y coordinates, which go up or down, which would be our b, the distance between those two, squared, would then equal, now again, it doesn't say c squared on here, d stands for distance, obviously, but again, think about how do I get rid of a square? Basically, I take the square root of both sides. And so what I essentially did was I took that c squared and I took the square root of that to just be left with my distance here, and I had to then take the square root of the entire thing. So this essentially is just the Pythagorean theorem, just manipulated a little bit so that then we have coordinate points as opposed to as opposed to side lengths. Now realize again, we're going to have to work on our math a little bit, because this is what gave some people trouble last time, is just realizing just the logistics of everything. It's really complicated. So let's do a couple practice problems. So let's take the problems that we just did before, and I'd like you to try to fill in the information. Sometimes it's easier to just do, okay, x1, y1, x2, y2. So I got my -2, 5, 4, and -3. And so if you do that and you write it out that way, it's really easy to realize, okay, if I'm going to plug it into my formula, what's my x2? Well, it's 4. What's my x1? Well, it's -2. There really is no difference in between whether I start with the -2, 5 and the 4, -3, as long as I'm consistent. So as long as I'm doing the second coordinate first, and then the first coordinate, and then the second coordinate, and then the first, then I should be okay. Now, again, when I substitute in, I always substitute in with parentheses. You should have learned that last year, because I don't want you to get confused. It's 4x2 minus whatever x1 is. Well, x1 is a -2, so I'm left with minusing a negative. So if I'm going to simplify this, negative then would become a, hopefully you said, positive. Now a -3 minus 5 is then equal to, they're the same sign, so we're going to add them and keep the same sign. And so 4 plus 2 is equal to 6, and -3 minus 5 is equal to a -8. Now, again, this is where we keep our parentheses in there, because if you're going to use your calculator, 6 squared is going to be easy, that's 36, but it's a -8 squared. If you plug this into your calculator, please make sure that you put parentheses around it, because it's going to screw up your answer if you don't. If you don't put parentheses, it's going to square the 8 first and then make it negative. But because the parentheses are here, this means -8 times -8, which means it's a negative times a negative, which is equal to a positive 64. Now if I add 36 plus 64, I get 100, which should then look familiar, because if I take the square root of 100, I would get d is equal to 10, which is the same exact answer that I had before. Last problem, all right, and so I'd like you to try this one on your own. So pause it real quick, try to see if you can get an answer, and then I'm going to go through the steps to getting my answer here. So if you could pause it for me, try it, and then we'll continue. So the distance, again, x2 is -3, x1 is 1. Now, I didn't put parentheses in here necessarily, because technically with the first one here, it doesn't quite matter. The parentheses are just going to drop off. Same reason with the -5. But I still have a -3 minus 1, which is equal to a -4, and I have -5 minus 7, which is equal to -12. -4 squared, which is a -4 times a -4, which is equal to a positive 16, and -12 times -12 is equal to a positive 44. So I would do 16 plus 144, that would be equal to 160. Take the square root of that, and I'd be left with d is equal to 12.65. Now on the proficiencies itself, it's going to ask you to round to the hundredth. This number here is round to the hundredth. The first spot is the tens, the second spot is the hundredths. And so that was one of the biggest downfalls from last year, was that people didn't realize that they had to actually round. So if I forget, which I hope I don't, please remember to read the directions carefully and know that you're supposed to round to the hundredth. If it says to round, you need to round correctly. That is it for our lesson today. All right, we will go over a couple practice problems again in class, so please have this prepared. Thanks for listening, and we'll see you next class period.